Usually, what we're going to be talking about is how rules are configured, how the rules are uh, established and ordered inside firewalls. We'll touch on a little bit of firewall technologies and firewall implementation configuration near the end. But again, it's the firewall rules, firewall policy, some limitations to that, the enhancements, and lastly, we'll talk about the management interface. So, what do firewall rules? Well, firewall rules are what are used to uh, control the flow of traffic. So here it says traffic rules use traffic filter traffic using rules or filters. The filters are basically instructions that evaluate and take on traffic traversing the network. What does this mean? Well, this means that you have certain attributes, which are could be your source and destination, and ports being used or protocols being used. Um, if you look at the code of this, it's basically a bunch of if then statements, if then or statements. That's basically how a firewall rule is constructed. So if, source equals, this network, etc., and, if source, so there are a bunch of XORs, so if source equals this, and if destination equals this, and protocol equals this, and port equals this, then allow. That could be a firewall rule. So these are used to create how traffic is going in and out of a firewall. When traffic enters the firewall, it's called ingress. When it leaves the firewall, it's called egress. So from the internet coming into your network, that's called an ingress traffic, INGRESS. For traffic going out of your secured network, it is called egress, EGRESS. So those are good terms to know and understand. All right, so firewall rules are two kind of philosophies or stances. The first one is the golden rule, and this is the default deny rule, uh, or sometimes it's known by deny by default or deny all rule. Uh, a lot of times you'll see this constructed, and it's always at the bottom of the firewall, and it's any, all deny. So it's a catch-all rule at the bottom for that. So it assumes that all traffic is malicious and at least unwanted or unauthorized, and everything will be prohibited by default. Um, in some older circumstances, where they have a default allow rule, and this is like kumbaya. Everyone thinks that all the traffic is good and, everything should be allowed out, no stoppage of information. Well, as you can see, that is not very much used. You may see something like this on internal firewalls only in rare instances, but you won't see it all that often out there. So these are kind of two philosophies. A, the world is evil. A, the world is, or B, the world is good. So let's talk about what comes next. And this is the slow transition. So the default, or the deny by default and allow by exception. All right, this is how 99.99% of all firewalls are configured. Uh, and here's it says the benign desired authorized traffic is identified, the exceptional grants access to the network. So at the bottom you have the default rule. Every rule you add above it can be an allow rule. You cannot have any allow rules listed below the default deny by default rule. Most firewalls nowadays won't let you add something to that. So if you want to say allow all outbound traffic on port 80 and port 443, this would go on top of that rule, and this would be an exception rule to the policy. So you're denying by default policy, and you're allowing by an exception. Uh, so this kind of lets you only specify what traffic you want to explicitly specify what is out. Um, it has an allow list like action, whereby only defined exceptions are allowed. Now we get to the default deny by exception. This is kind of like you would see more of this in an IPS or IDS system, where you have that. Uh, as you're identifying malicious traffic, you create traffic to block it. So essentially, when IDS IPSs are in learning mode, uh, they act similarly to a firewall, but they allow all traffic to traverse through them unless something has been added to it that says, hey, this is bad, block it. So these are kind of the only other instance where I can really think of where you would see a deny by exception. Um, Now, if it's on a firewall itself, you have to be continually monitoring the system, and then you have to add rules to block it whenever you see something that comes in. And these are terms like blacklist or deny list actions where you would put blocks in there for a lot of things that could be malicious. All right, so here we have an example of some rules here in a firewall. Now, as you guys are starting to get in your labs here, you're going to be able to configure your pfSense firewall rules. All right, so you can see the number of traffic here. And at the very bottom, you see the deny all rule here. Okay, and as you come in and look, it says IPv4 source, asterisk, or, the asterisk the wildcard, or it's sometimes in Unix, it's called the splat. So you see any IP4 traffic, any source, any destination port, source port, destination port, any gateway, uh, comes in and, uh, it shows that these are all deny rules because it has a little deny symbol right here with a little circle with the slash through it. There's some other rules that are more specific deny rules above it. So as you can see, TCP/IP4, any traffic using SSH on port 22 uh, is denied going into the DMZ network. And it doesn't matter where it's coming from or wherever, that will always get denied. Um, OpenVPN is also looks like it's getting blocked by this system. And you can see anywhere that's going to go through the firewall automatically stop and drop the network traffic there for OpenVPN on port 1194. So here we are. Whenever you're defining your firewall rules, when you have, when you're creating firewall rules, a set of firewall rules becomes a security policy. And we're not talking about governance policies here. We're talking a firewall security policy here. Um, so if the policy does not create predefined rules, you cannot follow the simple procedure. You need to have these kind of concepts. Inventory all business processes and communications that cross that firewall or checkpoint or uh, whatever you want to call it. Next, you have to determine the protocols, ports, and IP addresses of all valid traffic for both internal and external hosts. So you have to have that inventory of all the different things out there and what ports the traffic is using. So what we would then use is creating the rules and use a firewall rule designer or simulator. A lot of times I did all these in Excel where I would show, kind of similar there. I'd put, rule number, and then I put my, source, address, source port, destination address, destination port, destination protocol, and then I would have a little thing for allow or deny. And then I would have a note in there if I had to have a NAT rule for that also. So you kind of write out these rules, and most modern day firewalls have the ability to, you write out the rules and you can run a simulator on the rules before you actually apply the policy. So you want to use this and test out the rules in a safe, non-production environment to validate, because if you do it in production, you're going to have potential issues where you might cause an outage and then everybody will be mad at you because, hey, the network's down, and you could cause loss of business productivity, and nobody really likes that. So once you have that, it's always good to have written approval for the rule sets from a change control perspective. And a lot of times this means you would go to a review where you would have other members, either a peer or senior board review, senior members review all the configuration changes that are planned along with management, and you would be there to answer questions about potential changes that are made and why these changes are being done. And you would have to validate it, in front of, usually it's on a conference call with, 3, 4, 5 other people. Sometimes you won't even have to be on the call. You just submit a form. They look through it and make sure there's nothing in there, and they check the systems for potential conflicts, and then they'll give you a formal approval to proceed. What also you need to do once you have this done, there should be a system of record where the rules are recorded and a step-by-step plan is created to submit and amend the security policy for the inclusion. So you need to have hey, here is how I'm going to implement these rules. A lot of times these can be done in a form that's also utilized for the written approval, but you would follow this sheet okay, the first rule I'm going to create here, and put all these elements in, second rule, third rule, etc., how many rules you're going to make, and then when you're going to set it up to deploy those rules at a certain window or time to do that. So those are some things you need to follow as good practices for that. Next, we talk about the common types of firewall rules found on most firewalls. So HTTP is the access to the non-secure websites. Access to HTTPS are SSL or TLS. SSL has been deprecated, so most everything is using TLS 1.2 or 1.3 these days. You want to also have access to other internet website protocols. At times, maybe SQL, Java, etc. Usually you're seeing less and less out there because most of these are, are included inside of an HTTP packet using some kind of a TLS tunnel for that connectivity. And those packets are more on the raw, on the internal networks in there. SMTP and other POP, other email protocols, IMAP, all those can be utilized through your firewall too. They handle inbound email and outbound email also. All right, so now we look at the inbound and outbound communications. So how does this work if I have to have two-way communication? Well, most network communications are two-way exchanges, and these are called sessions. Most of you have taken TCP/IP would kind of maybe understand this. If you don't, basically, I like to correlate this as to making a phone call. One person picks up the call and initiates the call. Once the receiving party answers that call, you start a conversation. In networking terms, that is called a session. So you can establish that session and two-way communications can go across. One person talks, the other one listens and responds with other things, and that's how a conversation's supposed to go. Um, Now, a firewall would see this as a session from the source, whoever initiates the call, to that destination. You do not have to create a reciprocal rule allowing that same traffic to go outbound. The firewall will understand that the response for that session would allow the traffic to go outbound on that. So, a lot of times, if you're only allowing inbound traffic, I've seen too many firewall engineers make that mistake. Like, well, I'm going on port 80 to this, and then they create a rule for outbound. So internal systems could go outbound on port 80 and 443, and then they create a inverse rule saying everything from on the internet can go to those systems on port 80 and 443. So you're opening up a reverse network. You're exposing a lot of things to something that doesn't need to be, because your focus is on this. You only need to have one rule that allows the traffic to go out one way. So rules usually allow inbound responses to initial outbound requests, uh, and the single rule can sometimes define both the outbound and inbound communication parameters. So make sure you consider the rules that manage the inbound communications uh, from external sources. Limit those down to only the bare necessities. Do not make those reciprocating rules. All right. So what do we get next? We're talking about rules. Uh, Access control lists are not rules. They're not filters either. Rules are. This is how the rules are written, though. They're basically essentially an access control list, but rules have a little bit more additional filters that they call on in there. So rules are written expressions of an item, a concern, actions take place. I already talked about that a little bit earlier. Filters are kind of the same as rules, but they're intended to emphasize the intention to block something or deny unwanted uh, items in there. So if you have filters for certain phrases within HTTP stream, uh, or SQL stream, drop all tables or something like that. If you're looking for that phrase, that filter will scan all the data of that and grab that out of there. Uh, Rules are kind of like the expressions if source destination, yeah, if and then that. So an access control is the ability to grant or deny access based on first off that comes is uh, based on your authentication. Uh, so you have to know. Remember, we talked about authentication. It is uh, who are you? So you have verify and validate who they are, and then you check to see if they are allowed to use something. That's how an access control list works. So remember that synopsis of the or scenario of the bouncer at the really fancy club, and he checks to see if you're on the list or not. Well, if you're not on the list, you're not getting in. If you're on the list, you might get into some parts of the club. And if you're not on the secondary list to go into the VIP area, you're not going to get in the VIP area. So we have that. Uh, the next is the focus on controlling the user's or client's access to a port. So does that client have the ability to go on port, 443 for outbound traffic or something like that? So we're looking at that access control list, how it applies to certain, ports and protocols in that environment. Okay. So next, let's talk about how are we going to create our firewall rules. So now we know the difference between rules and firewalls kind of do, it's kind of now become gray fuzzy area for everybody. So the first thing you need to determine when you're going to create a rule, um, what is the protocol going to be? Is it going to be a TCP based rule or a UDP based rule? Because remember, TCP/IP stack is broken up into three protocols, base protocols: TCP, UDP, and ICMP. Now, TCP is Transmission Control Protocol, uh, and that allows for sessions. UDP is stateless and user datagram protocol, and it does not kind of create any kind of state. So firewall rules that use UDP, uh, they're kind of funky to deal with because there's no way to really do a lot of session-based controls for those. And of course, ICMP, this is more commonly known by all of y'all as doing a ping or trace route out there for that to see, the pathway stuff. So most people don't allow ICMP traffic through their firewall. We'll just go ahead and stop that there. All right, so now we're going to talk about source address. Your source address is an IP address, IPv or IPv6. This can be a individual host, a range of addresses, a subnet, or any, and that's ANY. You can set, a rule that says all anywhere it comes from for a source IP address. The next part is a source port. Very few applications have a source port. All right, and these are very cute. So most all source ports are going to be set to any, but you can set a source port for a specific set of ports or a range of ports, greater than or less than, or anything, or you can use the any symbol. So there's a lot of things you can use for your source port out there. All right, next you're going to look in your role is you're going to create your target address. So where are we going to head to? So what is our destination? And this is usually an IP address of how we're going to get to that, from that source to that target or destination address. Again, it could be any IP address. It could be it could be a subnet. It could be a range of subnets. It could be any ANY for any and all addresses on the on the internet or on the internal network or wherever you want to do. You don't care if you're filtering anything on that. The next one is your target port. Your target port can be a specific port. It can be a set of ports. It can be a range of ports. It can be any. This is usually where you define, like, if it's HTTPS, you're going to say 443. If it's HTTP, you're going to say 80. If you're going to say it is, uh, you know, DNS, you're going to say UDP 53. Okay, or 53 out there, port 53. And then you're going to have an action out there. Your last part of your rule is going to be your action. And these are going to be allow, deny. Um, you can say, you can compound these and say allow and log, deny and log, deny and alert, allow and alert, uh, allow and log, allow, log, and alert. You can set all these different combinations there for those. The only two things you cannot do on the same rule is set allow and deny on the same rule, because then it goes boom. All right, so let's look at a firewall rule here. So we have our action here when we're creating a firewall in pfSense. The first thing to do is your action. It can be pass or drop. You can see if the rule is disabled. You can set up your interface where the rule is going to be, where uh, packets must, from where, from which. So this is where the packets are going to be coming in at. You're going to select IPv4 or IPv6 there to show your thing. Your protocol is going to be TCP. So these are some of the configurations you're going to see in that. All right. So when you look at your rule again, we're going to go back to those little slides here. You're going to see the protocol, and that's going to be, whatever protocol you're going to be using. You can be generic with TCP or UDP or ICMP there. And this is a real simple firewall. So your source address, and a lot of times it's going to be any, or it could be a specific set of systems that you're going to allow to go to a certain system. And it's always good to be discreet with these things. So if you have source and destination addresses where you're allowing connectivity to, this is especially very good in B2B solutions. So you have restrictions of minimizing the attack surface through your firewall there. So you have your source address, you have your source port. That's always usually hard to do because ephemeral ports come into play, so you can see that to be difficult to use. You have your target address, and this is where the packets are headed to. And then you have your target port and the port which it's going to be. And then you're going to put your action of, allow or deny. And then you could have your log and alert and all those other ones associated with that too in that part. So let's look at an example of an outbound rule here. Uh, you have your protocol TCP/IP. You have a subnet here of 192.168.42.0/24. So it's a nice little Class C private subnet. Uh, it's coming from any source port, going to any destination target address, and here it is on port 80, and the rule is allow. So anything on the internal can go to something external for you. All right. So the next one are outbound rules. Here's another example of an outbound rule for uh, internal traffic to go out on port 443. So you have any website, if it goes on secure SSTLS, this would be the rule for that. Let's say you want to block internal clients from accessing internet-based FTP clients. Well, you would set up your internal rule for 192.168.42/24, just like your other ones, except you're going to put the port 21 there, and then you're going to set the rule to deny. So that's pretty simple to see there. Now, let's say you're trying to do some publishing for inbound rules. So the source and IP address are often any from, coming anywhere from the internet. Let's say you're publishing websites here. So you're going to say, okay, a rule that publishes any host client to an insecure website hosted on 192.168.42.98. So as you can see, TCP, that's for your HTTP protocol. The source and source IPA and source address are any. But you have your destination to be a specific IP address here internally, and on port 80 with an allow action. Now, if you want to deny, let's say, Telnet coming in on that same system, you would do the same kind of rule, except you would replace the port with port 23, and you would select that rule to deny. All right, so here is a rule set here, and we have it kind of in a table of all the different rules we were kind of talking about creating. With our favorite one down here, our default deny rule, we're publishing two rules. We're publishing SMTP on port 25 here, on the third rule from the bottom, and port 80 on the second rule from the bottom. We're allowing all of our internal traffic to go anywhere out there on the internet. And we're also publishing everything on 192.168.42.1. So I'm not sure what that is, but hey, we're allowing everything in there and we're allowing everything out from there. Oh no, we're actually not allowing. I'm sorry, we're denying. My bad. So this is what a firewall rule set looks like. So remember, the second golden rule of security is keep it simple. Keep it super simple. KISS. Keep it super simple. and keep the rules as simple as possible. Make sure they're discrete, they're easy to read. Uh, if you can combine ports for things, you can do, but do not like combine addresses and groups of things. So make sure every rule has documented. A lot of firewalls now have a comment field which you can document what that rule is for. I would always put the project ID for that rule so it could always be traced back to a project where it was added in the comment section. Um, I would also make sure I use change control methodology to track the rule modifications. That's going through that approval board and all that to validate and verify everything. And then always confirm the default deny rule uh, before you make any changes. Because that default deny rule used to be able to be modified. And I would see people go, oh, I'll do a, you know, uh, I saw somebody actually was being very lazy, and they created at the bottom, right above the default deny rule, an any, all, allow. Right above the any, all, deny. So what did that do? That just let everything in and out from anywhere, and the firewall basically became useless at that point. So just be careful when you're creating those type of rules. Well, that person did end up getting terminated for incompetence. So, ordering firewall rules. So the direction matters. So yeah, you need to validate what are your source and what are your target addresses, and validate what they're there. Um, if you put the wrong rule first over another one, like that person did create that, they created other rules like were like whole subnet wide that allowed everything to go through, and then there were more discrete rules underneath it. When we were logging and finding out, hey, why is my rule not working? We found somebody went ahead and created a rule above our rules, which we were using to track the traffic. Their rule was catching the our traffic in there because they created a rule in the wrong order, and so when a lot of times we're logging it, it created this logic thing that did it. I've also seen people put a deny rule above an allow rule, and uh, they usually catch something that shouldn't be caught. So here it says place your deny exceptions first or early in the rule set. Uh, Make sure you're not stepping on anybody else's rule that's a specific allow for that. Because a lot of times we've seen business continuity issues where something has gone down because of that. So, um, one other thing, you want to put rules pertaining to more common traffic, the most commonly used and highest used rules. You want to put those near the top also, because once a packet hits a firewall and the rule is processed and allows, it doesn't have to keep using cycles to evaluate all the rules, in the system. So once it hits a rule that's allow, the traffic is allowed to go out, and we're allowed to move forward. Um, Again, and let me reemphasize this: the universal deny rule should be the last and final rule. And it's always better to use fewer rules than more rules, because I had one firewall at a place I worked at had close to 5,000 rules on it. It was quite immense, and every time we pushed policy, it would usually take 2 to 3 hours for a new policy to be uploaded and compiled and processed. So that's something you want to do, is kind of make sure your rules are consolidated and you reduce duplication. Um, One thing you want to do is make sure you have a thorough inventory of all network communications. It's important to have all this documented. This includes the ports and protocols in use. as well as the source and destination addresses that utilize them, so we understand those traffic paths and patterns. If you actually come into an organization that has this, count your blessings. I have worked in many organizations and consulted with many organizations, uh, and none of them have had this. Once they create the rule, they throw the piece of paper or spreadsheet away, and nobody keeps a centralized repository of what their traffic flows are. Um, you need to also determine and prioritize traffic that is considered, mission critical, important, uh, optional, uh, personal recreation list. You can create these categorizations. A lot of times we'd see these color coded in the firewalls. You could create filters that create color coding, or you could see these in spreadsheet documentation where they could be ordered up and all that. And you would also have a field in there that would say, yep, this is mission critical. If the firewall goes down, these are the rules that need to get written first. And, if something happens and you have to bring back something, you would have that there. Um, you also want to make sure, and this is common sense here, block any traffic that is malicious or deemed unwanted, either through a deny or utilize the default catch-all rule there for you. So that leads to the question: what should you allow and what should you block? Well, these are ones you want to block. These are like your ICMP traffic originating from the internet. Uh, any traffic that's headed exactly to your firewall, you want to block that. You don't want it connecting to your firewall. Uh, any traffic known to close ports, so you don't want to like have somebody doing a port scan on your system. So you want to block anything that's not open. So avoid those any allow rules. Um, anything used by malware, uh, inbound TCP/IP53. TCP/53 is DNS, but is used for zone transfers. A lot of times you want to block inbound UDP53 because a lot of external DNS they want to query your internal network to kind of get a feel of what is in there. They can just start making a lot of DNS queries internally and seeing what your internal list is like. Um, you can get subscription to IP addresses that are blacklisted, or you can create your own. And this is just a deny list. The terminology blacklist is kind of going out of style nowadays. Most of the times they're being called deny lists. Um, a lot of this terminology, like blacklist, whitelist, demons, these were all created by folks who played Dungeons and Dragons and created the early stages of documentation for this. A lot of times you're getting executives that just kind of weren't nerds and they don't follow this kind of uh, logic and they don't understand what these items mean. Um, Contrary to a popular TV show that was once out there called that, they just, it's easier for them to dumb it down and say, these are the allow list, this is the um, deny list or drop list. Okay. Um, Also, if you have traffic coming from a network segment or from IP addresses that you know are not in use, but you're seeing it, you may want to deny it because that could be an indicator of traffic that is being spoofed. So, so when we're going to look for this, whenever you do an essential elements of a firewall, the first thing you want to go over is the guide for installation of the firewall. This tells you how to configure the firewall and all that. Or installing the operating system. The next part is the guide for configuration. And this tells you how to configure interfaces and all that. Also, it's good to have a guide or tools to assist in troubleshooting. There's several tools out there like Firemon and others that are real popular that help, do all this. You got to follow guidelines like COBIT and ITIL to kind of look and follow those, methodologies for change control and checking for the differences. And then you need to make sure that you have consistent filtering across all firewalls. So you need to make sure you need to validate and verify that the rules and policies are going to be the same across firewalls. So you can have traffic traversing all those and not get, you hit 2 or 3 firewalls and get dropped by the fourth. That would be bad. So other things on the firewall policy that need to address is what needs to be logged. So you may want to just, a lot of folks will say, I only want to log what's allowed. If anything's getting denied or dropped, since we're not allowing it in, I don't want to log it. That's fine. That's a fine thing to do if you want to do that. You want to specify logging location and redundancies. So a lot of times people will point to a SIM server, system event logging, where it can be consolidated. A lot of times people use Splunk or something like that. You also need to show where you want to store those logs, and that usually ends up pointing to a SIM. You also want to have people that will review the log files to make sure they're good, instead of have it good there for monitoring and making sure that something doesn't look out of the ordinary, so they have to be understanding of it. You also want to look to see what add-ons or enhancements you want to use. So there could be stuff like geolocation stuff that's out there, or geo-IPing that you can say, okay, I want to block all traffic from Antarctica. You could do something like that. You would say you could add in web, like other plugins where they do content filtering in there and all that too, that come into play also. You want to have rules and set up on how to access configuration or management interfaces. These can be, establishing a connection that only occurs through a single bastion host, and have permissions and all that to control those management on that management plane. You want to make sure you have logs on the location of the firewall and how to access it, maybe through a lights out situation, where you have data loss or connectivity. You can use an ILO to do a remote console shell to the system. Or you can actually physically have to know the location, rack, grid number, and a data center to go find your firewall. You also have to know what kind of physical access is needed, and that includes, is it in a cage? Is it in a rack, a caged rack within a server cage? That's inside a data center with guards and access control. You know what I get. So we get in there. Uh, then you have to figure out what kind of backup and redundancy is present. So if you have them clustered, if it's in 2 firewalls is enough, or if you need like 32 firewalls, all with the same policy acting redundantly for a lot of bandwidth. A lot of data centers have that kind of stuff out there. You also want to look to see what you're going to use to manage encryption and where to use it and where to disallow it. And this includes monitoring your what crypto algorithms are being utilized and disabling the crypto algorithms that are getting deprecated. So you want to, if you have a list in your configuration, it's possible to create a thing where a crypto algorithm, you can negotiate down to an algorithm that is, quote, broken, and that could violate your security there. So you want to go ahead and say, yeah, let's not use triple DES anymore, and things like that. Those are things you want to kind of look at to manage that encryption. And then you also want to look to see how IDS IPS interacts with firewalls. If an alert comes in, you could have it automatically create a firewall role that's out there for you. Okay, so now we look at the limitations of firewalls. So firewalls are basically software. And what does all software have? Bugs. So there are programming errors that can happen in firewall software that can create vulnerabilities. If you go and search every firewall vendor and look at the CVE database, you'll find several of them out there. Uh, there are plenty of people that will go out there and try and exploit the software coding bugs. So that's the second item listed there. Another thing is if software can be pushed through a buffer overflow, this can happen. A lot of times I remember firewalls being susceptible to the what was called the ping of death. This was an ICM packet that would hit a firewall, and then it would have a data section inside the ICMP, which would make a reference to data outside of the range of the packet, causing that overflow and all that. There's also firewalls can be susceptible to fragmentation attacks. This is where somebody has a router that sets an MTU size so low that a normal packet gets split up into multiple packets and it keeps getting forwarded onto the internet until it's the firewall. And since the firewall is having to process every packet based on a full rule set, this could cause a firewall to have a lot of undue pressure and utilize a lot of processors, times, and stuff. So we have that there. Um, you can have overlapping where packets are uh, overriding each other, where um, they have in the TCP/IP header, there's a sequence, and it could say 1 through 15 in a packet. The next packet comes in and has, you know, 8 through 23, and we have that overlap there. Well, that can cause a firewall when it's trying to reassemble packets to choke. Um, Internal code planting. If any of you ever review Huawei, you can see that uh, those firewalls and routers all came within built-in backdoors that were being accessed by the government of a certain Asian country. So those were out there for that. And then, of course, you have the denial of service and DOS flooding systems that can happen. And this is where they just send tons and tons of packets at a firewall, and that just kind of overwhelms it, uses up all the ports, and makes it do a lot of processing and allows legitimate traffic to not make it through. All right. So let's talk about that fragment and overlapping. I kind of described it just before. And as you can see, for normal fragmentation occurs where you have more data, packets too big, the data is too big, so we split up into two packets. Well, here we got overlapping data that is broken up into multiple packets here, and then therefore the IP header would end up being discarded. And here it kind of is, and that could end up, bringing together information that could introduce malware into a system that is utilized to avoid that detection. So that's something to cause an issue there. All right, so if you want to improve performance, speed's a common concern. Everyone wants faster, cheaper, all that. It's as we go in more and more to fiber optics, speed is increasing, but it's still the more speed, the more cool stuff that occurs. We wouldn't have the stuff that we have now if we were still on modems. We wouldn't have streaming video or any of that kind of stuff, or streaming audio. You guys wouldn't be able to use your Spotify's or Netflix on your phones or any of that stuff. So Now, the firewalls that all these streaming services are you going through uh, do need to be configured to allow the highest wire speed possible. So you're trying to get them as close. Now, firewalls, because of the processing they do, they reduce the speed. So we want to make sure that the latency or delays in that communication are reduced to as little as possible. Uh, Consider this: if you ever early days in VoIP phones, we could say hello, and then you'd hear the other person go hello back to you, and they would have that delay in there because it took a while for it to get through. So things that were used to improve firewall performance were caching, and this was creating commonly saved objects that were static to be used over and over again. Like the first caching we would ever see were like the headers and logos of all the major websites. Uh, the firewalls and proxies would start caching those. And then you were able to add more lines in by using load balancing. So if you had, multiple firewalls, that load could be spread out among multiple firewalls and they could process them faster. Um, High availability is associated with load balancing and network availability, along with redundancy in there. So you would have, let's say, multiple ISPs connecting into multiple cables coming in, multiple T1s, T3s, OC3s, um, all those type of connections coming in for you. Um, and these were measured as a percentage of time when the service was available. These are like, your 4 nines, 5 nines. This was your availability of those systems and how they were measured. So improving performance, the caching kind of held, static content in the memory or on a storage device that has high speed. The content was retrieved from cache instead of it going across the network and back, and was used by proxies a lot. Load balancing, this is a distribution of the workload across multiple firewalls or multiple systems. Um, because of this, it allowed for deeper packet inspection while maintaining that wire speed. So if you had uh, a session going across 5 firewalls, uh, it could analyze that traffic 5 times as fast. So here is kind of what load balancing looks like. Our private LAN is going out to the internet. We have a little circle with a little pseudo X in the middle of it. That's a symbol for a load balancer. This could be like something like a F5 or something. And we have 3 firewalls. The load balancer will load balance the 3 firewalls and go out through that other load balancer on the other end, or whatever. It could be a switch or router. That could be, switches and routers can also do load balancing functions too. So you may have a Cisco load balancer in there, Cisco router load balancer. These are all devices that can be multifunction in the network. They can do all these functions for you. All right, so the downside of using encryption with firewalls. So benefits of properly used firewalls, they protect data in storage and in transit. So data at rest or data in storage is something there. So encryption does that. Uh, they provide confidentiality, so anything that's encrypted is not able to be read. And they prevent unauthorized third parties from snooping and looking at secured content, whether they look for it in a network trace or they look for it on the actual uh, if they connect into a system and they find the files are encrypted, they still can't get to it. Now, downside of firewalls, firewall is not intended to be a destination for encrypted communications. It's okay for traversal, but if you're using functions like caching uh, or inspection that would hit a firewall for that functionality, encryption, it doesn't really, you can't really do that. So encrypted traffic can't be filtered. So we can't have that content inspection in there. And it's not useful if your firewall is also doing something like anti-malware inspection or anything like that, uh, or that. And um, if you're using something like IPsec, there are problems with IPsec using network address translation. And IPsec is a VPN protocol using packet encryption as it traverses the network. We're going to talk about that later on in a few other chapters up ahead in the second half of this mini semester. So we'll have that there. But remember, the firewall is unable to decrypt and encrypt that without specific modules that enable it to do that. All right. So if your firewall is deployed as a SSL TLS endpoint for allowing web traffic, there are certain firewalls that have this web portal on there where you can publish applications. Citrix has a device out there. There's other devices out there. Microsoft has a device. Cisco has one where you connect it into their firewall-like system. And once you log in, you would have access to kind of like an extranet. And these are applications that are published through a web server. You connect to these through SSL on that. So that's a way for SSL endpoint to allow traffic going into a web point. And so these are usually called captive portal or something along that for portal traffic. Some of the firewall enhancements that are out there these nowadays. Remember, the simple firewalls didn't have any of this stuff. Now, our next generation firewalls, they offer integration for malware scanning where they can actually inspect packets. They have integrated IDS and IPS features, or they can integrate with external IDS IPSs. They can also be used for VPN endpoints, so you can establish a either SSL TLS uh, tunnel to them, or you can configure them like using a proprietary VPN protocol that creates encryption, usually based on IPsec, where the endpoint is the firewall and it will do that for you. They also can be utilized as unified threat management devices, which is a fancy term for saying we combined a lot of these other features together. And nowadays, especially with cloud deployments or virtualization, there are now virtualized firewalls that can be utilized. Um, Lastly, we need to address how to control the management. If you actually go out there and read Zero Trust security or Zero Trust networking, the concept is dividing up into your network into two areas. The first one is your data plane where all your data would traverse. The second one is the management plane, which should only be accessed by administrators and not be exposed to common users out there. So you want to keep that in mind when you're configuring a management interface. Um, the management interface on a firewall can end up becoming a command line or graphical user interface. The idea is to secure the management interface, physically or logically. So you don't want to put it on your same data plane network out there. You want to put it on a management only network that can only be accessed by administrators in a controlled function. You want to have strong authentication, maybe even the use of a one-time username password, like through something like CyberArk or something like that to do that. Or you want to have a controlled administrator group. You don't want to ever use the default administrator accounts on there. You want to have something that can log those changes of any administrator making configuration changes on that system. Um, you also want to consider the communication pathways. So you have a management plane, and then you might also have a lights out ILO system, which allows communication in case you have network problems, and you have a redundant way to connect through, let's say, uh, a KVM, a remote KVM system into the monitoring port out there for that. Uh, you want to make sure that the management interface is not configured on any net on any port that is configured for internet connectivity or external connectivity. You want to make sure that that's a big no-no. You also want to configure the firewall to record every attempt at connecting, uh, whether it's successful or unsuccessful, to the management interface into a log file. And then you want to make sure you verify all the settings have remained as configured. So here's an example of accessing the pfSense system through an SSH terminal. You can see it's based on FreeBSD. You're running on AMD 64. So you have your pfSense in there. You have all your options in a menu item. You select your menu item in the shell and you move forward. So that's what you want to do there. Here's an example of the GUI interface, and as you can see, it's a web-based interface that you can control, and it goes through all that. So in summary, today we talked about firewall rules, firewall policy, firewall limitations, firewall enhancements, and management interfaces. Lastly, I want to touch on, get ready for your midterm exam. There are 50 multiple choice questions. There are 2 points each. They cover chapters 1 through 8. So best of luck to you. If you feel you need to challenge any kind of question that was marked incorrect in the test, I need you to send me a reason and an explanation of why you answered it that way. And then give me an external reference that supports your reason out there. Show me like a website or a link or a snippet from the chapter, page, and something. I will go look that up to make sure it's valid. Because I've had other students challenge me on some questions. I'm like, you know what? Your answer, based on this information, could very well be valid, and it could be an acceptable choice. So with that said, good luck on your midterm. Best of luck, and I'll see you after the midterm, and get ready for Chapter 9. Talk to y'all later.